Hello, welcome to the Marchanaut Show, the cybersecurity show. So the Go programming language keeps getting hacked. So we're going to break this down in this video, right? So the Go module mirror supply chain attack, right? Let's break that down. It happened, kind of recently. So researchers basically at Socket uncovered a major, supply chain attack, targeting the Go programming language, right? And the ecosystem. So the attack involved a malicious package on github.com, which impersonated the legitimate and widely used, the github.com, the Bolt DB. Peter, you could put that on the screen as well. So the attacker, basically exploited the Go module mirrors caching system, right? Allowing the backdoored package to persist and remain accessible to developers for over 3 years. Now, here's the information about the attack details, right? You have the typo squatting technique, where the attacker published a package with a name, nearly identical to the legitimate Bolt DB module, which is basically a practice that is known as typo squatting, right? So developers who mistyped the package, name, could basically inadvertently install the malicious version. Now, the initial publication, the malicious package was first published to GitHub in November 2021. So the Go module mirror caching is another factor, right? Once published, the Go module mirror, which is basically operated by Google, cached the malicious module indefinitely. So even after the attacker reverted to the GitHub repository, basically to a clean version by modifying the git tags, the cached backdoor remain available to anyone fetching the module from the proxy, right? Now the impact, the backdoored package granted remote access to infected systems, allowing attackers to execute arbitrary commands. So this posed a significant risk to basically thousands of organizations using the legitimate Bolt DB module, including major platforms like Shopify and Heroku, right? Now, the attack went undetected for over 3 years, highlighting the risks of indefinite caching and the challenges of distinguishing between legitimate and malicious packages when, names are nearly identical. Now, that's that. But here's a breakdown of the most significant and reoccurring vulnerabilities that were found in Go-based applications, and I'm going to provide examples and references. So the command injection, that was, Go applications that use the os/exec package to execute system commands, basically are at risk if they pass unsanitized user input to these commands. So attackers can exploit, this to execute arbitrary commands on the server, leading to data breaches, system compromise, or service disruption, right? The unvalidated input, right? Failing to validate user input can expose Go applications to various attacks, such as SQL injection, cross-site scripting, and others. The proper input validation, so using regex or type checks, is essential to mitigate these risks, right? Unsafe use of pointers, so Go supports pointers, and unsafe or improper handling can lead to vulnerabilities such as buffer overflows or use after free errors, especially in performance critical code. There is a URL parsing issues as well, so inconsistent URL parsing between different Go versions, notably before and after the 1.17, can lead to request smuggling and unauthorized actions. For example, the parse through vulnerability occurs when front end and back end services use different Go versions, allowing attackers to bypass security controls using crafted semicolons in URLs. There's improper authentication and authorization, so APIs and endpoints not properly secured can allow unauthorized access to sensitive resources, right? So Go applications must implement robust authentication and authorization checks to prevent privilege escalation or data exposure. There's the OS command injection, so the CVE 2018-7187, the Go Get tool in older Go versions allowed remote attackers to execute arbitrary OS commands if the insecure flag was used with a crafted import path. The fix, upgrade the latest Go version. There's the improper certificate validation, so the CVE 2018-16875. The crypto/X509 package in older Go versions did not limit work during certificate chain verification, enabling potential CPU DOS attacks. So the fix for that is update the patched Go versions. There's the error handling flaws, the CVE 2018. The vulnerabilities in error handling, such as the Kubernetes written in Go, have led to critical security issues, including privilege escalation and remote code execution. So regular updates and careful error management are required. So when a security issue is reported, the Go security team follows basically a structured workflow, which includes, triage and assessment. The team reviews the report, assesses the impact, and determines the urgency. There's patch development. So if the issue is confirmed, a patch is developed privately to prevent premature disclosure. The coordinated disclosure, the team works with the reporter and, if necessary, with other affected parties to coordinate a responsible disclosure timeline. The release and communication for the Go team, the security patches are, released as a part of regular Go releases or as out of band updates for critical vulnerabilities. The Go team publishes data or detailed security advisories, including information about the vulnerability, its impact, and remediation steps. So this process is designed to minimize, risk and to users and to ensure, that patches are distributed efficiently and securely. Now, here's, the Go community has established clear channels for reporting vulnerabilities and actively participates in the security process. So key aspects of the community response include the reporting mechanism. So users and researchers can report vulnerabilities privately to the Go security team, which ensures sensitive issues are handled responsibly. There's transparency. So once a patch is released, the Go team provides public advisories and change logs, fostering transparency and trust within the community. There's collaboration. So the Go project encourages collaboration with external security researchers and other open source projects, especially when vulnerabilities affect multiple ecosystems. There's the adoption of best practices. So the Go community follows industry best practices for patch management, including phased rollouts and testing to minimize disruption and ensure the reliability of security updates. So here's what Go can do to improve its security enhancements and, best practices for Go security, because, it keeps happening. We got to patch, right? I'm gonna need better, things from you, Go. So there's the input validation and sanitization, right? Enforce strict input validation to prevent injection attacks such as SQL injection and cross-site scripting, right? They can provide more built-in or standard library support for input sanitation, right? Or sanitization, right? And encoding to reduce developer error. Authentication and authorization, enhanced standard library support for secure authentication and authorization mechanisms such as the OAuth and the RBAC, that's the role-based access control. They can encourage password hashing using secure algorithms like bcrypt, Script, or Argon, and secure token management, right? And dependency and vulnerability management as well. Continue improving tools like Go vuln check, or that's basically for low noise, actionable vulnerability detection in dependencies, automate regular auditing of dependencies, and make it easier to update or patch vulnerable packages, right? They can use secure defaults and language features, adopt more secure defaults in libraries and frameworks. Defaulting to HTTPS, secure default flags, consider language level features to further limit unsafe pointer usage or restrict potentially dangerous operations. Concurrency safety, provide more guidance and tools for detecting and prevent race conditions, which can lead to a subtle security, bugs. Integrate concurrency safety checks, more deeply into the development workflow. Integrated security, instrumentation. So encourage or provide built-in support for runtime security instrumentation, allowing real-time detection of vulnerabilities as data flows through the application. Error handling and logging. So standardized practices to avoid leaking sensitive information in error messages and logs. Make it easier to mask or redact sensitive data in logs by default. Static analysis and code review. So expand static analysis tooling to catch a broader range of security issues, including unsafe pointer usage and unhandled errors. Promote regular code reviews with a focus on security, possibly with built-in or third-party tools that highlight risky patterns. Education and community guidance. So continue to update and expand official security best practices documentation, making it more accessible and actionable for developers. They can foster a culture of secure coding through education, community examples, and security-focused code reviews. Now, Go's current strengths, they have memory safety via garbage collection and strong type system reduces many classes of vulnerabilities common in C/C++. There's the static/standalone binaries with no system-wide dependencies that help minimize the attack surface. Tools like GoVulnCheck and a curated, vulnerability database help developers identify and remediate known issues efficiently. Now, the potential, language level improvements, they can do stricter compile time checks for unsafe operations, more expressive type system features for security critical code, such as taint tracking or capability-based security, enhanced support for security or secure cryptographic operations in the standard library. So that is what I have for you today. Please take a moment right now to hit that subscribe button and like button. If you like this video and you appreciate it and you want more videos like this, please let me know that right now by hitting that subscribe button and that like button. I appreciate your viewership. Stay safe and see you on the next video.